Hello and welcome. So this is uh, double E paper 2019. So what we are doing is we are going through the linear algebra question. So far I have solved multiple papers like CS, ST, MA, EC, and from all of these papers I have solved the linear algebra question. And if you want to practice and if you have problem, then you can look at the solution. So you can go through that because if you don't have the PYQ for data science and artificial intelligence, it is good to look at the all paper of that have the similar, that is the common thing, right? So let's look at this what we have here. So we have few questions. So let me see that. uh, Okay, so we have here question number 2, that M is 2 by 2 matrix with eigenvalue 4 and 9. The eigenvalue of M square is. So this is the easy one, right? If some matrix A, you can decompose it into S lambda S inverse, where S is this. You put your eigenvector and form this matrix S, and this lambda is the diagonal matrix, and in diagonal elements are nothing but the eigen elements, right? If you take the A square, that will be S square lambda, sorry, that will be S lambda square S inverse, right? So all the eigenvalue will get squared. Then for M square, the eigenvalue will be 16 and 81. So correct answer for this is 16 and 18, that is D. Okay, now let's move to next question. So in next question, you see that you have to find the rank of the matrix, and how you can do that. You cannot pick this as a pivot. What you can do is you can bring this third row to first position and this first row to third position. There is no harm doing so in matrix, so you can do that. So the first row will be at the third position and the second row will be as it is. Now what you can do, you can pick this as pivot, and now you can apply the elimination. And what you can do here, the first row will be same, and second at the second row what you are going to do is subtract the first row from the second row. So you are going to get 0 here, and 0 minus 1 is minus 1 here, 1 minus 0 is 1, and here we will have as it is. Now you can pick this as pivot, and now you can apply the elimination. The first row will be as it is, and the second row you can put as it is, and third row you can add these two row. The main goal is to eliminate this. Here the main goal is to eliminate this, right? So you can pick the third row. So here it will be 0, you can add up, there it will be 0, and you can add up, here it will be 2. So you see that you find the 3 pivots, right? So you can say that the rank of this matrix will be 3. So the correct answer for this is 3. Okay, now let's move to the question number 26. What we have given is this matrix M, and what we called about this v1 and v2, that is are the column vector. So M, you can say that this is 2 by 2, and this v1 is the first column and v2 is the first column, and this is 2 by 2, right? And suppose M inverse is this matrix. So we have given this M inverse, and we have given this u1 and u2, and we have told about u1 and u2 that these are the row vectors. So these are the row vector u1, and so u1 is this one and u2 is this one, right? Again this will be 2 by 2 because this is M. Then if this is M inverse, then it will be again 2 by 2. Now we will have to check this statement, right? So you see that if you do the multiplication, but what we have looking for is the inner products, right? You see, if you look at this statement, what we are looking is nothing but the inner product. So the main point is that we are multiplying two matrices, that M and M inverse, right? So if you know that M inverse is equals to M, so you multiply both ways, you are going to get the identity matrix of 2 by 2, right? So you pick this one and you write this M inverse. So and M inverse is nothing but this u1 transpose and this u2 transpose, right? And now you are going to put here M. So M is nothing but this is v1 and v2, right? And you do the simple multiplication. Now you are going to do like this, right? So it will be some u1 transpose u2, and that multiplication will be equal to identity, right? So 1 0 0 1. So this product is going to be 1. So you see that this here u1 and v1, right? So u1 transpose v1 is equal to 1, and this is going to be 0, that you will multiply this u1 into v2. So u1 into v2, right? So u1 into v2, that is going to be 0, right? And this u1, what the heck? So u2 into v2, right? So u2 this, so you just compare with this, right? So you have given this identity matrix, you take the inner product, then you will find that which relation holds true. So both relation holds true. So the correct answer for this is C. Both the statements are true. Okay, this was the 2019 paper from EE. Now we will look at this 2018. 2020. Right. Thank you.